Well, welcome back, everybody, to the latest episode of Digital Ag Global, your go-to podcast for everything ag tech. Um, today we're going to be talking about how every crop nutrition recommendation that a farmer receives, and that's essentially applying the right kinds of fertilizer at the right rate, the right time, and the right place, should be based on science, experience, and economics. Advice for crop producers should be based on real evidence, such as years of field trials, soil sampling, yield measurements, statistical models, and debates among scientists. And I think that applies whether you're talking about large farms with thousands of acres of production or small holder operations in many parts of the world. The economics, the agronomy is similar despite the scale, the differences in the scale. And behind most of that work is behind the scenes. What a farmer sees are numbers on a fertilizer bag or the nutrient content of a bulk blend, the invoice, an extension leaflet, or a screen in an app. Today, we want to talk about how digital tools can help use all that data and knowledge to make the best practical and profitable recommendations for farmers in a way that they can easily access. Yuri?
Thank you, Clyde. Guys, welcome back to Digital Ag Global. As always, tuning into the great episode we're going to have today. And as you mentioned, agriculture is a field of huge opportunities and huge challenges, and agronomic research is one of the kind of biggest questions in the equation. And today, we have a great guest that will help us to kind of define how research organizations actually generate agronomic knowledge, how they create those recommendations, what tools they are using to create relevant agronomic recommendations, and also how those recommendations can be later delivered to farmers themselves in order to help them benefit with a better yield, better economics, better return on investments. Before we jump into introducing our guest today, I just want to remind our audience that Digital Ag Global as a podcast offers sponsorship opportunities. So guys, if you want to become a part of our network, have access to speaking opportunities, have access to all the insights, feel free to let us know, and we'll help you to join us on the journey of popularizing digital agriculture globally. And also, if you're interested in building your AgTech products or you want to support with your AgTech adventure, reach out to Cultivate and we'll sort you out. With this said, let's introduce our guest today, a very interesting and immersive topic ahead.
Okay, our guest today has spent his career on exactly these kinds of problems. Dr. Samuel Njoroge is a scientist and core competence area lead for site-specific fertilizers and agronomy management at the African Plant Nutrition Institute. And I know Samuel well from my previous role in the fertilizer industry and have a tremendous respect for the kind of professionalism and science-based work that the African Plant Nutrition Institute does. The APNI is headquartered in Morocco, and Samuel is based at the APNI's East and Southern Africa office in Nairobi, Kenya. He holds a PhD in plant production systems from Wageningen University, and before joining APNI, he spent 7 years with the International Plant Nutrition Institute's Sub-Saharan African program, leading the 4R nutrient stewardship projects across Eastern Africa and working on decision support tools for site-specific nutrient management in smallholder systems. Samuel, welcome to the show. Glad to have a chance to chat with you again. And before we get into the research itself, could you tell us how you ended up in the field of plant nutrition? And maybe you could talk a little bit about the important and extensive role that APNI plays in African agriculture.
Thanks a lot, Clyde, and thanks, Yuri. Happy to be here to be part of this exciting discussion. My journey into the world of agronomic research. I think started about 20 or so years ago when I first did my undergraduate internship. So for my undergraduate internship, I got a chance to intern at the International Center for Tropical Agriculture based in Nairobi. And during that time, then I got exposed to the research world, to the world of soil sampling and analysis, to the world of experimental design and seeing how scientists work from a problem that has been identified, say, in the literature, or maybe identified by farmers in the field, and how they then develop scientific methodologies to address this problem. And this really excited me because I think naturally I'm into a lot of problem solving. So initially, it's not, to be honest, it's not an area that I'd thought of, but the more I got to know into it, the issues to do, then once you do the experiments, you get the data, you analyze, you see the patterns, and then try to come up with solutions from that. That really excited me. And then from that on, once I went back to complete my undergraduate, I sort of made my mind, this is a journey I want to take. And subsequently, I went back for my MSc in that area, and then, continued onwards, and then gradually got into that path. And here I am many years later working as an agricultural research in this great continent. And in terms of APNI, so the Africa Plant Nutrition Institute is a not-for-profit science-based organization that uses science to try and solve issues related to poor soil fertility and food production challenges across the African continent. And the whole idea is that IPNI has a mission of ensuring that we have farmers who are nutritionally secure and food secure based on effective plant nutrition. And our mandate runs across the entire continent, while we are headquartered in Morocco and also with our East and Southern African office here in Nairobi, Kenya, covering the East and Southern Africa region. We also have our West Africa office in Yamoussoukro in Ivory Coast, taking care of our interests in Western Africa. But also collectively, is in spite of these specific locations where we have our offices, we do have footprints through projects, and also working a lot with partnerships, working with universities, working with national research institutions across different countries, and also with other like-minded partners to implement activities across the continent.
Okay, well, thanks, Samuel. I think it would be helpful for our audience if you maybe talk through a little bit of APNI's approach to developing the science, the knowledge that farmers need, and then how you work with other stakeholders in Africa and the many countries of Africa to disseminate that information and help people make good recommendations so farmers can make the best possible use of the fertilizer that they have. And I think also you may want to talk about the particular challenges of fertilizer use in Africa, given its low usage rates and the impacts that has on yields and profitability for farmers.
Sure, Clyde, and I think I'll start from the end part of your question, because I think that makes one of the most crucial, challenges that are in the region, because as we all know that fertilizers are critical for sustaining soil fertility and also for increasing and sustaining crop yields, because as crops grow, they take up nutrients from the soil. And if these nutrients are not replaced, then what happens is that they'll get depleted from the soil, and then you have poor fertility soil that are not able to sustain good production. But then the challenge is that across Africa is that fertilizer prices are actually, farmers face the highest prices compared to other regions in the world. And this is because most of the fertilizer used by farmers in Africa is imported out of Africa. So when you add on the import cost, and then in particular also the port charges and also the inland trucking cost from, say, the coastal port to the time it gets to the farmers, at times you find farmers are faced with fertilizer prices that are up to 2 times what farmers, say, in the global north are paying. And this is also in a setting where these farmers are, on average, low-income farmers with smaller parcels of land. And because of this inability then to supply their soils with the nutrients that are required to restore their fertility, then you have these cascading problems where you find that because they are not able to replenish the fertility, then the crop yields are low. And then because the crop is low, and this is what they rely on for their food, and also in other cases for part of their income, then their livelihoods also suffer. So then at APNI, then our work, how we try to address this is to work with multiple partners, because we are not a very big organization. I think our staffing is just about 45. So our biggest impact comes when we work with partners to be able to work at scale. And principally, we do have different approaches how we work. And one of the most critical ones is working through on-farm experimentation, where we, instead of maybe working in a certain research station to try and find out which technologies or recommendation will work, we work on-farm with farmers themselves to try and first of all, based on what is their pain point, what issue are they facing, so that we are not the ones defining the problem, but it's the farmers who are saying that, for example, I've realized that in certain parts of my field, I get very poor yields even if I use the fertilizers that have been recommended. So, and then we find that maybe this is a recurring problem in a certain region, and we try to address this to see, okay, then what could be the issue, and then going back to the drawing board and to design trials that we feel, based on our scientific know-how, are able to address this problem, and progressively then working through multiple sites and season together with the farmers to see what treatments are working, what options are working. We co-evaluate with them, and additionally also ensuring that other partners, including the fertilizer industry, including cooperatives, including government agencies, are part of the process, so that it's not a one-person-led process, is a process that is led and owned by different stakeholders, so that by the time we are arriving to a common consensus that this is potentially the issue, then I think everyone is on board. And then an important part of this is that after developing this sort of scientific recommendations, which could be packaged maybe in the publications that we do, is ensuring that then this same information is distilled and distributed in different forms that are feasible. For example, in forms of extension products that extension agents can use and work together with farmers. Also in terms of maybe small advisories that farmers can take on board, working also with farmers during field days to pass on this information, so that, because ultimately the most important thing is that the information and recommendations generated are able to reach as many stakeholders as possible.
Yeah. So in reaching the stakeholders, and obviously the most important stakeholders are actually farmers, but then you've got agribusiness, government officials, and a host of other people that work in this space. The challenges of reaching so many smallholder farmers in the vast geography of Africa is immense. Can you talk a little bit about the kinds of digital tools that you're using at APNI to facilitate this collection, processing, and dissemination of data, across the continent?
Yes, you're right. It's a massive continent, and even when you work in an individual country, you're working across vast regions. So the use of digital technologies, it becomes quite important. And I think over the years, we've seen quite some transition in how we're able to use these digital technologies. For example, some years back, starting right from data collection would be purely paper-based, where you're in the field, maybe recording data on yield. Someone is there measuring yield on a scale, and then it's been recorded on paper, and then later on that has to go back to the office, and then someone has to sit and type it down. So right now we are moving more into digital forms, using things like ODK and Kobo Collect, where you have real-time data entry at the field using tablets or mobile devices. So first of all, at the collection level, you ensure that there's this is fast track, that at the same time that the data is being collected, it's sort of been later on been backed up in a server somewhere. So you reduce this time lag between data collection and also an entry, and you also reduce chances of data losses, because sometimes you could be in the field and someone capture the data on paper, and then some papers are missing. This could be a challenge. But then also using these devices like taking advantage of like some drone technology that is emerging to even collect images of the farms, and to be able to collect additional data, because beyond now the data we are able to measure at the plot level, like what are the yields, if you fly drones at different times during the season, you're able to see how the crop was growing. And sometimes you can pick up some variation and see maybe at a certain lower part of the field, the performance was like this and this. And when you then later on try to relate this data to what you captured, you may identify patterns that you are not able to identify before. Also, things like NDVI sensors are important to help to be able to assess the condition of the crop, and also things like digital soil, grain moisture meters. All these are digital devices that help at that ground level. But then later on, after you move on from the field and you've collected the data, digital devices and software still become highly relevant, trying to, during your data cleaning, to identify, if you had any omissions, if you had any errors in the data. These are very crucial because before you move on to detailed analysis, you need to review the data critically, conduct what you call the preliminary analysis, see whether, maybe an extra zero was added, that may inflate yields and things like those. And then moving forward to processing this data, analyzing it and disseminating it before we even can run it, say, in some models that are able to give more insights to that. So there's a whole range of ways that we do use the digital devices, right from the data collection to processing and analysis, and even to dissemination. Because again, for example, if we want to give feedback to farmers on this is what we found and everything, one of the most effective ways is, again, pushing that through messages and everything. Most of the farmers across the continent will have access to a mobile phone. They're able to receive this information and also even translate what does it mean for your farm in terms of what do you need to apply, where can you get it, and tailoring it down to something that it now makes sense for the farmer.
Yeah, traditionally, extension, knowledge transfer in all the world and including Africa has been that person-to-person contact. You have an extension officer or a fertilizer company agronomist, or even peer-to-peer farmers talking to other farmers. But when you have so many smallholder farmers in Africa, that is highly inefficient. And so it's how promising is mobile technology as a tool to reach farmers directly?
Mobile technology is very promising because, as you mentioned, then the ratio of extension agents to farmers is quite low. You may have one extension agent maybe covering a certain big region that has thousands of farmers, and the ability then to be able to access each farmer timely is a challenge. But then with the digital devices, you can have maybe 20,000, even 100,000 farmers receiving the same information at the same time. And some of this information could be time sensitive. For example, if it's advice on the right timing for planting, we have experience over time that traditionally in a lot of areas you could, within a few days, be able to estimate when rains will commence, for example. But nowadays with climate change and everything, there's a lot of variability in that. So if, for example, you want to push advice on that, based on the information that has been received from the meteorological centers, we expect some rain next week, maybe starting from Monday. This is information that at the push of a button can be sent to these digital devices, to the mobile devices, and the farmers know that we're anticipating some good rains next week. It's time to ensure that our fields are ready. So they become critically important. And the other thing is that some of this then, because of the feedback mechanism that is being allowed by some of the mobile platforms, and also using some of the AI technologies, there can be a sort of back and forth between a farmer who says, okay, this time I want to plant maize, maybe. Last time I planted beans. What should I do? What do I? So you can be able to tailor information instead of having the same information going to everyone, because this farmer wants to do this, or they may say, okay, this time I know that I need to apply maybe 4 bags of NPK fertilizer from my maize, but I don't have enough money to purchase, but I do have access to some manure. What can you recommend? And then based on the recommendations that are there, then the advice can be tailored and delivered to that farmer in near real time, so that they are then able to use that. So it becomes a very effective tool for that. And when you layer in things like the ability for some of these technologies even to translate into local languages, because again, another characteristic across Africa is that there's huge diversity of languages spoken across the continent. So, and even the extension agents and other stakeholders can maybe only speak so many languages. Then this unlocks additional value that you may have the same message, but it's tailored into languages that other different farmers can understand, and sometimes even into audio audio formats that they can listen to, so that even if they may not be able to read that, then they can listen in. So it becomes very critical, and it's probably one of the most important pieces of technology that is has come out in the recent past to help disseminate extension information.
I mean, one of the interesting things about Africa is the leapfrog that Africa's taken in mobile communications. We still have a lot of copper for communications in North America. I assume that's probably true in Ukraine as well. But Africa kind of leaped from over the copper and wired mobile communications to just mobile wireless communications, and that's, I think, underestimated when people look at the African continent. Yuri, maybe you want to, from your experience with in this area, what do you see as some of the most promising digital tools for Africa?
Thanks, Clyde. For sure. We've done quite a bit of work with different AgTech companies in Africa, in East Africa, and also West Africa. And first of all, from I just want to kind of add to what Samuel mentioned. I think the biggest challenge for African agriculture is generally access to inputs, fertilizers, access to distribution channels, and advisory knowledge. And there are a lot of different kind of ways or solutions how to handle these challenges, but having mobile-based technology has been proven worldwide and in Africa as well as the simplest, the easiest way to get information to people. And the way that African countries have been leveraging mobile technologies is fascinating, because mobile money, very simple technology, very powerful technology, exists only in Africa. We don't have that. The way people receive recommendations, some of our clients utilize a very simple but very handy solution like WhatsApp bots. So you can just type into your user, to your farmer, say, hey, you can buy this fertilizer at this rate, and then you can apply it. Very simple, very useful. So I guess the bottom line is innovators in agriculture and people who do a research and then trying to kind of spread the word should focus on delivery methods that are already there, that are already existed, yes, and just kind of utilize them to get it done. And I think there are quite a few good examples out there how people use simple technology to deliver a lot of value.
Mm-hmm. Yeah. So I think that one of the most important things that the African Plant Nutrition Institute has been doing is championing the cause of bringing the 4R nutrient stewardship system to agriculture. That's supplying the right source of fertilizer at the right rate, the right time, and the right place. And I think one of the important developments has been the adoption of the 4Rs by the African Union and other regional bodies in Africa. What role can digital play in adapting that 4R fertilizer recommendation system to the wide variety of different climates within Africa, the different cropping systems? And not all farmers in Africa are smallholders as well. So there's different scales. If 4Rs is the language, how do we, disseminate that information, and what role can digital play in promoting that?
Yeah, you're correct. You're right that APNI, the for nutrient stewardship is one of our flagship platforms in how we develop and deliver recommendations for improved fertilizer use. And then, of course, with the African Union recognizing this, and this is now included as part of the Africa Soil Health and Fertilizer Action Plan in terms of delivering forward-based recommendation. But then you realize that still there's need for some specificity, because, for example, if you start from the source that you say that for this this is the recommended source, but then there would be a question that maybe this source is not available in a certain location. So would it mean that then this farmer should not apply anything? And I think the answer would be no. But then this is now the role of the digital would come in, maybe to propose alternative sources, maybe even if it's a combination of two sources that are able to deliver the nutrients that were identified to be important for that area, and which form the basis of the initial source. Another thing is that if you look at rate, for example, recommendations for rate usually come in terms of, say, apply 100 kilograms per hectare. But then translating this into kilograms of a specific source, because you find that different sources will have different nutrient proportions. So how does this translate? The other thing is that one farmer they may have access to two hectares farm, another one maybe has 10 hectares, another one half a hectare. So how are they able to use this recommendation that comes in terms of 100 kilograms of hectare? So then the digital devices, I think they could have the technology to now, if a farmer is maybe able now to enter the size of their specific farm, and then this can be a simple calculation to say, then for you, it means this much for your size of farm. And then even if that they can now additionally offer details on this is the fertilizer source that is available, and these are the exact nutrient rates. So now it can even further tailor this down to say, for your farm, you actually need 5 bags of this fertilizer, because this is the information that makes most sense to the farmer. Is not when we tell them apply 100 kilograms of N or apply 50 kilograms of P. This will not make a lot of sense to them. They won't, because when they buy their fertilizer, they don't buy it in terms of nutrients. They buy in terms of a 50 kg bag of this fertilizer, say DAP fertilizer or any other fertilizer. So they want to know. So this is the information that they can use to go to the shop, and then they can see, if I need 5 bags, what does it mean? How much is 1 bag? So do I have enough? And things like this. In terms of timing, you realize that, for example, one of the most crucial things with respect to timing is issues related to rainfall, especially when you're doing like your top dressing and everything. The idea should be that the top dressing application for your nitrogen should happen during a period where you have some reasonable moisture on the ground. So maybe you've had some light rains, but then if it's during a very dry period, the recommendation would be not to apply. So then if you have a digital device that is connected to satellite sources of weather data that can give ideas that in the next 3 days is expected to rain, so the farmer can know that, well, maybe they had a rough recommendation to maybe apply their top dressing at maybe 30 days after planting, and today is 30 days after planting, but it's been a dry period. It's not proper to apply now, because then your fertilizer will be lost. The plant is not able to take up. But then if the app is able to recommend that in 3 days' time we expect some rainfall, that then they can be able to use this information now to fine-tune further this for our components. So these are all ways in how they can play. In terms of the placement, you see that they can get advice depending on what you do know that you do find that from one crop to another, there are different placement methods that are best recommended. For example, for your maize, which usually has a fairly good spacing between plants, spot application works best. But then for other crops like beans and soybeans that are sowed at a much closer distance, you find that banding is a more effective way of doing your placement. So again, information like this that maybe you can feed in that I want to grow maize, what is the best placement method for me? Then you can get that recommendation being pulled in and coming out to the farmer. So yeah, these are some of the ways that I see digital devices helping to further bring forward to be locally relevant to farmers, because it's only when they're relevant in this way that they'll be able to be useful.
Yeah, I mean, I think it's interesting in where in Canada and, United States, Ukraine, I think other large Brazil, often the ability to manage or to make adjustments mid-season in terms of fertilizer are just simply too difficult or uneconomic. Whereas one of the advantages of a smallholder system, if your farm is 1 or 2 or 4 acres, you can be more intensively managing that cropping system and actually take advantage of some of the nuances that can come from digital technology to actually maximize your crop production, maybe more so than a very large farmer in another jurisdiction might be able to do. Yuri, do you want to talk a little bit about your thoughts at this point?
Well, I just want to mention that we worked on a very similar technology, basically the digital tool that allows you to plan your fertilizer programs based on your geographical location, local weather, and available fertilizers, and get personalized recommendation. Because I think that the bottom line, this recommendation, they should be personalized per farmer,
Yes.
per his plot, per his weather, per his crop. So, and that's one of the biggest advantages. The one concept that is very interesting for me to explore, how this research, agronomic knowledge is getting translated to actual insights. We all agree that the insights should be actionable, but how is this research from like data sets, field work become an actual insight? What does it take? How it works? I think that's very underestimated part of this kind of cycle.
Yeah, you raise an interesting point, and I think this is one area that because mostly it sort of happens in the back end that it's not well understood in terms of the nuances around it, and also the rigor, and also even the logistics around it. So if you imagine now, if you're trying to develop or even improve on certain fertilizer recommendations and for a certain region, so if we are even to sort of walk through the entire process, this is a process that could start, say, from literature review to find out maybe what are the key, what is this area like, what are the soil types, what are the typical farming practices, what's the topography like, is it a generally flat landscape, or is it characterized by hills and valleys? Because all these are things that will influence even if your soil was initially fertile, based on whether it's on the upslope or the bottom slope, because of years of washing away of the topsoil, will have differences. So to first of all get that understanding, then go to the specific area, conduct some baseline surveys to get more detailed characterization of the area. What are the major crops that farmers crop? Is it maize? And if it's maize, for example, is it a continuous monocropping of maize, or do they have legumes in the systems which can bring different benefits and also have different priorities in terms of nutrient use? And then after understanding this, then you can see if we are maybe trying to think of improved recommendations for maize, because we think the ones that are there, based on our assessment, they are not working as effectively as we think they should. Then we need to check, based on the data we have collected, which are some of the key factors that can influence the crop's response to the nutrients. Maybe it's the landscape position, that you have farms that are on different positions along the landscape. So you could have that as a factor. Then you could realize that maybe farmers also have different practices. You have farmers that have livestock, and over time they apply a lot of organic manure on their farms, and there are others that don't have. So the dynamics of these two different groups will differ. So you can move from selecting farms in different locations of the landscape, and then integrate another layer of how farmers manage their farms. Have farms that apply organic manure and others that don't apply. Maybe move to an additional layer of farmers who maybe just continuously grow maize, and others who grow others. So based on this, then this can form your stratification to say that then I want to set trials in this. At least I want to have a number of sites that represent each of these distinct conditions. Of course, you cannot cover every condition, but if you're at least able, based on the scientific knowledge of some of the major factors that influence crop yields at lower spatial scales, then you can have a good sense of, yeah, let me capture these 2 or 3. And once you have them, then you come up with an experimental design based on your key interest. If, for example, we had to use nutrient emission trials as an example, which is one of the tools that APNI has used a lot to be able to determine which nutrients are really important, is then you can have this structure where, if, for example, you want to know, based on from your main nutrients, the nitrogen, phosphorus, and potassium, and additionally even the secondary and micronutrients, which one is how are the responses differing? And then now you can design your nutrient emission plot, have your full treatment where you have your NPK plus maybe secondary and some micronutrients, and then you can have plots where you, for example, apply your PK and you meet your nitrogen, and then another plot you have your NK and then you meet your phosphorus, then another one you have your NP, you meet your K, and then a control plot. And ideally what you want to do is that we want then to keep everything else constant, in terms of the crop variety that you plant, in terms of the management activities, the weeding time, the planting time, keeps all constant, so that the only difference is the nutrients that are applied. And then ideally then we will want at the end of the day to compare, say the yield we got in the NPK plot was 5 tons, and then in the one that we did not apply nitrogen, we got 2 tons. So that's a difference of 3. So we can say that by not applying N, we missed out, by omitting N, we missed out on 3 tons of yield. So, and then maybe for phosphorus, we got we only lost 2 tons. So based on that, then across, then this is just for one field. Then we check across the different farms, see some farms it will be higher, the response, and others will be lower. And then the question is, under what conditions do you get a higher response? Under what conditions do you get a lower response? And this is where your analysis comes in also, to based on the factors that you used in your classification, also based on additional details like your soil data, because ideally you should also, prior to the onset of the trials, collect soil samples, analyze data, collect rainfall data also, and importantly also not just run this for one season, because seasons can change a lot, especially nowadays. You have big variations between one season to another.
Historical data as well, yes.
Yeah. Exactly. You have about 3 seasons running, so that you see the variability, and then you can then move from this to develop response functions, and these are things you can fit into some of the tested crop models that are able to then use information to connect the soil information, the input information, to the yields you get. And ideally then, because you're not able to do experiments everywhere, you can be able to scale this out by collecting proxy data, say, based on the large maps that we have, the soil maps, say that if we have this sort of soil under this condition, what then the model can predict for you what would be a good estimate of the expected yield. And then based on this, you can come up with recommendations. But again, this is not the end of it. You again now would go back to validate these recommendations, see how are they actually working, work together with farmers, and also see whether they are reasonable for farmers, because it will not also, you may have recommendations that from an agronomic point of view, they make good sense, they give you high yields, but then they are very expensive to implement because the cost is very high. So you also need to look at what are the economics of it and everything. So again, work with farmers to see, and that for different farmers, you may find that they have different capacities to absorb the risk, and also access to resources to implement this, and have some sort of site-specific then packages that can help each farmer to now unlock value. So I think in summary, this is the sort of entire process, but of course in reality is much longer. It takes a number of years with a lot of people, a lot of resources to analyze the data. Sometimes you get seasons where maybe you had a drought season, you lose a lot of your field trials, and then you have to go back again. So yeah, but it's interesting work, especially when once you see some patterns coming in, and some things that you didn't even know would be influential, and then they start to make influence, and then you check literature and you see that the actually scientific basis for what you have observed. So makes it quite interesting in that sense. Yeah.
Well, I think it must be rewarding when you see in different regions, yields rising, profitability increasing. I think the importance of the opportunity of Africa to build economic growth and provide support for social systems is tremendous. And I think digital plays a key part of that. We've talked a lot of the podcast about artificial intelligence. The specific thing I'd like to ask Samuel is, Africa does have a data deficit when it comes to agriculture. There isn't I think the fertilizer and other field trials that we'd like to see more of, and that takes time to do. The on-farm data is spotty, even when it comes to the amount of fertilizer being used, the yields, all those kinds of data, and even weather records, etc. When you have sort of this fragmentary evidence of what's actually going on, is it possible to use AI as a tool to fill in those gaps using machine learning and the power of AI?
Yes, it's quite possible. Of course, nothing beats a complete data set. That's sort of the holy grail, and that's always on the top of our wish list. But then, in the conditions which we operate in, it's not always possible to find that. You do have instances of missing data. You do have instances, for example, data was collected and then it had geo coordinates, but then soil sampling was not done because maybe there were logistical issues to support the soil sampling and analysis. Rainfall data was not collected and things like those. Maybe some information was missing. And this is again where the power of AI and technologies like machine learning comes in, because then what you can do is that using this is that, for example, you can reduce, because first of all, it's very expensive to run all this work. So, you could save cost and time by, even overlaying your data with other data sources, like with spatial maps and everything, to see, for example, if I did some work in Eastern or Central Ethiopia, these are the sort of conditions, these are the soil types, this is the climatic conditions. What other areas, say within the East African region or across Africa, are similar to this? And if they are similar, then there's a chance that some of the responses then we got there are likely to be the same ones. So artificial intelligence can play a part in trying to locate. If we feed it to that, these are the characteristics of this region and everything, can detect areas that have near similar conditions where we'd expect similarities in responses. In terms of data, sometimes it's possible to get errors in data. It can be able, and AI will be able to pick out, some outliers in your data, because anytime you have errors in your data, this will, of course, skew your recommendations and, give you some errors there. So these are areas, and then even filling in some information, you may find that you're missing some specific details. You have maybe the longitude and latitudes, but you don't have good data on the altitude. Based on some of these coordinates, then it may be possible to pull in additional data on altitude that then allows you to unlock further insights. And then in terms of machine learning, once you're able, because previously the analysis would maybe work, say if I've done some work in Central Ethiopia or maybe in Western Kenya, I only analyze for that area for those seasons, and my insights can be limited. But then the opportunity to bring in maybe large data sets from across the region, and then now with the power of machine learning, conduct some detailed analysis, we're able now to move beyond say the typical ANOVAs and everything, and unlock patterns that would previously not have been able to see. And this you may see that we did recent some 4 years back, pulling about 7,000 nutrient emission data points from across Africa, and some of the insights came in. We started realizing that even things like temperature had an influence on some of your response functions, and these are things with smaller data sets you cannot pick out. Things like also your agroecological zones playing a part. So these tools are increasingly important, and as researchers, and particularly at APNI, we are increasingly moving to see how we can make the best use of this. also in terms of time saving, it also saves, because some of these tasks is like the data cleaning and everything, they can be a bit repetitive, and this, if you know you have the right prompts and everything, they can help to fast track this, to refine your code when you're doing the analysis. And it's essential, because I think Africa cannot wait anymore to get improved recommendations. So I think that there's a lot of potential in that.
Right. Olia is in the background, and I think we do have a comment. I think it's up on screen. Samuel, if you can see that the question is, what field evidence would convince you that a pre-sowing seed treatment genuinely improves nutrient use efficiency? So I don't know if seed treatment is one of your areas of expertise, but what are your thoughts on that, Samuel?
Yeah, it's not necessarily my area of expertise, but I think based on the general research principles, I think the evidence would then be based that the treatment design would need to be in a way that it allows us to test, to isolate the effect of the seed treatment. So for example, then would need to have had in our trials some plots that maybe didn't have seed pre-treatment, and then others that have a certain seed pre-treatment, and then all factors are then kept constant. And then if we have this well replicated within the field and across maybe multiple fields, and then once we run our analysis, that, and then crucially, then if it is in terms of nutrient use efficiency, what we would want to be looking at is that do we have evidence that in the treatment that had pre-treatment, we have, for example, higher nutrient uptake, and if this then is higher than compared to where we didn't have the pre-treatment, and then it's not just a random error. This is something that you consistently see in most fields, and when you analyze for this, you see significant differences. Then I think that will be evidence that this pre-treatment is actually resulting in improved nutrient use efficiency, because then if you have higher nutrient uptake, it means that the plant was able to take up more of what was applied when it was pre-treated, had the pre-treatment, compared to when it was not. So that's one of the things that I would look out for.
Yeah, I think it's an interesting question, and it points out that while fertilizer and plant nutrition are critically important for the success of agricultural systems, pest control products, the proper seeds, and even machinery that allows for better precision, application or seeding and fertilizer application, and all these things are all factors in the success of crop production. And I know APNI spreads its wings and delves into these things from time to time, and I know you've been big champions of precision ag. Yuri, do you have any thoughts at this point on
I have a very good question. I have a very good question to Samuel. We talk about a lot about how the process of research is done, how AI helps to handle data better. The question I have: does open source data helps? Like there are soil maps that are open source. There is weather historical data that is open source. Do you guys usually use it? Does it make sense to use it for this type of research? What are your thoughts?
Yeah, open source data is very useful for the work that we do. But of course, it's important to ensure that this is credible open source data that you know, because again, everything you do is only as good as the quality of the data you have. But yeah, increasingly, I think in the past 10 or so years, there's been a lot of enthusiasm within the research community to share data, open access, and there's also been an encouragement even from funding organization, from the institution themselves and researchers. So we do have a lot of a number of open source data that are credible. For example, we do have open soil soil information data for Africa at different spatial scales, and this data helps a lot because it's in the absence of actual soil samples and analysis at each point. This is your next best bet, and the resolution is improving incredibly with every passing year, and we're able to see that if you're able, then this is helping us unlock some insight that we could not have been able to unlock in the absence of this data. And then, so whether it's open soil data, weather data, all this is incredibly important, because there are some areas that based on their remoteness and everything, there's very limited data about them, but we don't want these areas to be left behind when we are making, trying to advance the research work. So yeah, it's incredibly useful and important. And I think this is one ways in which this is one of the parts that researchers across the globe are going into, trying to make information as more open source as possible. Again, it also reduces repetition of previous work that had been done, because resources are also not easy to get to. So if we can leverage more on some of the work that has already been done, then the better.
Yeah. Well, I think
Makes
we're coming
sense.
to we're coming towards the end of the time. I just want to say that if you're interested, if people in the audience are interested in any way in better crop production systems in Africa, I think the best place to start is to look for review all the material that the APNI.net website has. It's .net, right, Samuel? Still,
yes, definitely.
yeah. .net, great place, lots of incredible information, and certainly also to reach out to Samuel and his colleagues. Because they are the absolute experts in this area. Samuel, we gave you a heads up that at the end of the program, we'd like you to share with the audience your views on what is hot and what is not coming forward and in your field. And maybe if you had something to share, that would be a great time.
Yeah, thanks, Clyde. I think it's been an interesting engagement. The time has seemed to fly by. I think what is hot currently in our field is the whole issue of artificial intelligence and machine learning. I think it's grown in leaps and bounds in the past few years, and we are, as researchers, we also trying to get ourselves at speed to see how we're able to unlock the value that comes with this. Because but then what does not change is the need to collect good quality data, because again, as I had said previously, whatever output you get is only as good as the data you have. So this is something that is quite hot. Machine learning and artificial intelligence is helping us to unlock additional insights, and also open access data, and even things like publishing data. Previously, I think in our field, the typical practice was just to publish your paper and publish your results. But then increasingly, I think there's encouragement to publish data. What is the underlying data behind this? So this can be published separately and then accessible for other people, and then they're able then to maybe use it for additional insights and everything, of course, with the accreditation given where it's due. So these are some of the hot areas and that we are looking into. Maybe was not, but I think, yeah, there's still some challenges in there, and I think a big challenge currently facing is the issue to do with the research funding, because as I've mentioned, this whole area of agricultural research is quite a long-term process that but then sometimes some of the funding that we come across will be about for 3 years. So this can limit, your ability to come into the ground, diagnose the problem, develop solutions, validate them, and then pass them on to farmers and be able to document the impacts. You need a much longer time scale to be able to deliver on this. So these are some of the areas we are, talking with our funders, and I think they are welcoming to and getting to grips with this the need for more longer term funding that can allow us to unlock more insights beyond what can be, because a simple thing like a poor rainfall season could mean that 1 year's work was not effective, and if you imagine a 3-year cycle, then 1 year is quite significant. So these are some of the areas, and I think we are slowly getting there, and with the coming up of the tech solutions that are they're helping to support our work, because the typical work for a researcher is sort of never ending, and is always a full interest. So this is sort of helping to, at least especially for some of the routine things, to try and fast track them. So that is also something that we are all exploring, to see how we can make the most effective and right use of, but of course being aware of also some of the, you know, the challenges that could come with over reliance on these tools, because you always need the expertise there. So what is still required, we still need more people to come into the field. We still need boots on the ground for people to come in, because you cannot replace that human touch and actual human knowledge, so that even whatever feedback you get from whatever source you're looking at, you're able to distinguish whether, yeah, does this really make sense, and is this plausible, things like those.
Yeah, well, I mean, I think the limitations on artificial intelligence, well, it has incredible promise. When it comes to getting a recommendation or advice, trust is still a critical factor. And, you know, the kind of long commitment that APNI has made to scientific, credible, information has built a tremendous amount of trust. And I think that means that AI and organizations like APNI will have a tremendous opportunity to work together to improve outcomes. So thanks very much, Samuel, for all your insight today. And I guess I would turn it over to Yuri for a few closing comments.
Thank you, Clyde. General encouragement to our audience: if you're building a digital product that is focused on African market or digital agronomy, I advise you to go and partner up with organizations like APNI, because for a lot of cases, we very focused on how to get a digital tool or digital insight or forecast into hands of farmers or growers, but we rarely think about where this research or this insight comes from. And I think it's a very powerful combination when research organizations and innovators work side by side in order to create something very useful for the agri-food value chain. With this said, thank you for sticking around. It was a great episode. Stay tuned for a next episode in September, and sign up for Cultivate page and page of APNI in social media.
All right. Well, that's great. I've enjoyed the conversation today, Samuel. Maybe I'll see you in Kenya in the near future. And we're looking forward. We're now into our third season of Digital Ag Global. Please don't be shy about offering your questions or comments during future episodes. And if you do have comments or questions for us, feel free to send us a line by email, and we'll try and respond, but we would like some feedback. So thanks very much, everybody. Thank you, Samuel, and all the team. Say hello to everybody at APNI for me. Yuri, terrific co-hosting. Thank you for that. And we'll see you in September.